Kia ora and welcome to the Master of Aerospace Engineering webinar from University of Auckland Satellite Mission Operations Center. I'm Roberto Armallin and I'm a professor at the Department of Mechanical and Mechatronics Engineering and Deputy Director of Te Puneatea Space Institute. I'm an astrodynamicist, so basically I study how man-made object moves in space and how to guide them in order to achieve a space mission. My research also focuses on space situational awareness, which aims to ensure that space operations are safe and sustainable. Before moving to Auckland, I was a professor in different universities in Europe, including in Italy, UK, Spain and France. And I also had a company that I co-founded and ran in Italy, with which we perform a study with the European Space Agency. Now with me we have Lilian and AJ. Can you please introduce yourself?
Hi everyone, I'm Lilian. I studied Master in Aerospace at the University of Auckland, and I also did my bachelor's degree as a mechatronics engineer in the University of Auckland as well. Currently I'm working at Beca as a systems engineer. Our team mainly focuses on maritime and aviation systems.
I'm AJ. I studied at the University of Auckland as well. I did a Bachelor of Science majoring in physics, a Bachelor of Engineering majoring in engineering science, and then went on to do my Masters in Aerospace. I now work at Rocket Lab as an electron mission designer. My job is to have a simulation of the rocket and to make sure that all our mission goals are going to be met.
Thank you, Lilian and AJ. During today's webinar, we will share some key information about the Master of Aerospace Engineering degree, then hear from Lilian and AJ about their experience as graduates of the program. Finally, we will answer some questions that you have submitted. You can submit your question anytime through the webinar via the Slido link in the description section of this live stream. If you have more questions after the live webinar, please share your queries with us via the Ask Auckland link, which is also in the description. The Master of Aerospace Engineering aims to educate the first generation of aerospace engineers in New Zealand and prepare them for roles in the country's growing aerospace sector, both in technical and managerial positions, including entrepreneurial ventures. This program is designed for recent bachelor graduates in engineering or science who want to specialize in aerospace, international students seeking advanced aerospace education in an innovative and vibrant environment, and professionals looking to upskill or transition into the aerospace career. The program addresses the current skill gaps in New Zealand, expanding aerospace industry. It builds on University of Auckland's strong research capabilities of academics with many years' experience in the sector and established undergraduate programs in engineering. And it leverages cutting-edge purpose-built facility, including those of the University Space Institute, Te Puneatea. It also has a robust industry support, including from Rocket Lab and New Zealand Space Agency. The program is run at the University of Auckland City Campus in the Faculty of Faculty of Engineering and Design, and students can begin the semester 1 or 2, so at the beginning of March or in July. There are several programs available, each varying in length and structure. These are measured in points, where under 20 points represent 1 year of full study, and the standard course is worth 15 points. We offer a postgraduate certificate and a postgraduate diploma programs, which are taught only and designed to be completed in 1 semester or in 1 year. The postgraduate certificate is a 60-point program requiring completion of 4 15-point courses. The postgraduate diploma is a 120-point program requiring 8 15-point courses. For the Master of Aerospace Engineering, there are 2 options available: a under 20-point program, so 1 year of full study, a 180-point program, so approximately 1.5 years of full study. Both master options can be taken as either taught or research-based. The taught option includes 45-point research program alongside with coursework, and the research option includes a 90-point thesis with fewer courses. All programs can also be studied part-time, in which case the completion time is extended to double the time of full-time duration. The entry requirements can be summarized in this way. So you will need to have a bachelor with honors with the GPA greater or equal than 5, or an equivalent bachelor and PC certificate or diploma with GPA greater than 5. Also, we can assess activity performed in the industry and towards the entry requirement, but this will be done in a one-by-one case. So application follow the standard application process at the University of Auckland, requiring approval by the Senate and its representative. Students in the program will receive specialized aerospace training, complemented by a selection of elective relevant to aerospace engineering. The core courses include aerospace design, system design, covering the architecture of aircraft and spacecraft, their subsystem, and the process used to design and integrate them, aerospace structure and mechanism, that is focused on structural analysis and structural design for both aircraft and spacecraft, and space dynamics and mission, the course that I teach, which explores spacecraft motion, both orbital and attitude, control system, and mission design principle. To further deepen their expertise, students will undertake a research project or thesis supervised by experts in the field. This is a key component of the program and enables students to gain hands-on experience with the real-world aerospace challenges. In addition, students can choose from a range of technical electives such as computational fluid dynamics, advanced control system, and these are not exclusively aerospace focused, but they are highly relevant and widely applied in aerospace context. By completing the program, students will gain advanced technical skills in aerospace system, dynamic structure and mission design, research and project management experience through a substantial individual project or thesis, and strong teamwork and communication skills, including the ability to work in a multidisciplinary environment. In general, we have a pool of academics offering projects across a range of areas, including astrodynamics, space situational awareness, space structure, in particular deployable system, space system design, such as reaction wheels for CubeSat, space propulsion, laser communication, and remote sensing, including also drone technology. We also have several exciting ongoing projects, such as the design of low lunar orbit mission in collaboration with NASA JPL and Curtin University, activities aimed at improving how we track spacecraft in orbit, research related to flight dynamics and operation of satellites, including missions like METENSAT. The Space Institute include, in terms of facility, a mission control room and ground station, an environmental test facility with a thermal vacuum chambers and vibration testing, and facility for designing and prototyping and assembling spacecraft system, including the clean room. In addition, you have access to other university labs like wind tunnels, composite manufacturing labs, mechatronics lab, and structural dynamics lab. And of course, you have access to industry-grade software licenses, like, for example, MATLAB, which is highly relevant for our courses. Graduates will be equipped at the end with roles in aerospace industry, including companies like Rocket Lab, Dawn Aerospace in New Zealand, academia and research, including PhD pathways, and related industries such as automotive, telecom, and advanced manufacturing. Career paths include in the area of system engineer, structural analysis, mission planner, research scientist, and manager and consultant in aerospace project. So now I concluded this part about the information, and we will answer at the end some question about it. But I want to hear a bit more from Lillian and AJ about their experience. So starting with William and then with AJ, the first question will be, how did you choose to study the Master of Aerospace Engineering at the University of Auckland? So what bring you here?
I was lucky enough at the last year of my engineering degree, I was able to pick some of the aerospace paper as my elective, and that kind of sparked an interest and allowed me to find out that we actually do aerospace engineering in New Zealand. So I took the opportunity and I found out we also do masters. So that's when I signed up.
For me, during my undergrad, the aerospace industry was really taking off. SpaceX, Rocket Lab were pushing the frontier forward, and that got me really excited. And just with Rocket Lab somehow magically being in Auckland, New Zealand, it just seemed like a great opportunity to study my masters to help me best get in the door there.
Nice. And how was the degree helpful for your career?
So to me as a consultant, it's always good to have a variety of technical background, then support the projects that I work on. So the Master of Aerospace really provides that foundation for any projects that I get, I have a decent understanding of the systems, which was really helpful.
Yeah, so during my studies in the Masters, I was taught by Roberto, and we did the course he mentioned earlier, the Space Dynamics and Missions. And as an electron mission designer, that knowledge is really fundamental. Knowing what a launch window is, knowing orbital mechanics, it's just stuff I use daily in my job. Also, during my studies, I was lucky enough to get an internship at Rocket Lab. And I think having the fact that I was studying my Masters at Auckland was really beneficial, helped me stand out from my peers. And then finally, the research project I did with Roberto, I was able to present that to a group at Rocket Lab, which helped me stay on full time.
So can you share something you enjoy most about your studying during the program?
I enjoy learning so much details that I probably would never had a chance if I just finished my bachelor's and called it a day there. I was able to, I guess there's also the flexibility when I was working as a master student. I can decide when I need to focus on my projects as well as some of the courses that I actually take. So I guess a balance between my project workload and courses was really good.
Similar story. The flexibility of the research project allowed me to balance my internship with the study. And then additionally, the labs we got here are really cool. Just being able to see hands-on the different test facilities from the vibe table that are really crucial to developing a spacecraft.
Okay. And why it is important to advance your knowledge and skills with this master?
I guess as I've previously mentioned, it builds a really strong foundation comparing to some of the colleagues that I do have a strong aerospace background, and the project that we focus on, it provides more in depth to not just what's the goal of the project, but what the client really focuses on. So for me as a consultant, that was a very important part.
Yeah, as I mentioned, the industry is really just growing rapidly at the moment, and I think space is a great place to have a lot of impact on the world. It's quite ironic that space is the best place to help things on Earth because you're going around it so many times and you're in a unique position. For example, last year at Rocket Lab, we launched a number of spacecraft with a wide number of applications that are really helping people. Such as quite a lot of synthetic aperture radar satellites are going up, which they use microwaves to image the Earth, which is really unique because it works in all conditions, even if there's been there's cloud coverage or like an eruption, it can see through all that, so it can really get you information on the ground at all times. And then another mission we did was for NASA, where we put some spacecraft around the Earth's poles to monitor the ice caps. So it's just, you can do a lot of things in space that you can't do anywhere else. So getting educated in this field is a good way to help a lot of people.
Thank you, Lillian and AJ, for sharing your experience. And I think we are now in the Q&A session. So I will read some questions question we receive on Slido, and we try to give an answer. If we are not able, we will try to do it after the webinar. So are there opportunities to get industry experience connection while studying? I guess the answer is yes, and in two ways. When you select the project, essentially you also select a supervisor, so you agree on a project with the supervisor, and the supervisor working in the area, typically they have contacts in the relevant contacts in the industry. So if you are really interested in developing that interaction with the industry, is through the supervisor. Sometimes students might arrive with some network, some contact, and they can also propose a project to a supervisor who can accept that, and then so develop this project in collaboration with the industry. In the case of AJ, for example, the project was not designed in collaboration with Rocket Lab, but AJ had this desire to go and work for Rocket Lab, so we designed a project that was relevant for the company, and I think we succeed considering where he's working at the moment. Next question. What are GPA requirements in order to skip the master and go straight into aerospace PhD? So the main requirement for the PhD is that you already have carried out a research project. So this is a key requirement. And the GPA limit I think is around 6, but I need to double check. So 5 is for master, and I think 6 is for the PhD. And for scholarship, you need to have a GPA that is above 8 to be considered. Yeah. So if you take an aerospace class during your bachelor's at University of Auckland, how does that impact your master's degree? So yeah, this is something that now can happen because a couple of classes are offered as elective for mechanical and mechatronics. So in that case, my advice is to go on the research path, so that the project is the main element where you further deepen your skills, and you can select other courses that are not the one that you already taken. And there is one that is aerospace design that is not offered as an elective, so that is basically mandatory for all the options I described. How do I select my research topic project for the master program? So in 2 ways. So the academics usually maintain a list of projects, and you can access them through the Institute webpage. But I think more importantly is that you understand the area of expertise of the academic and you contact them, because maybe the list is not up to date or there are more recent projects that come up. So it's important that you interact with the prospective supervisor as soon as possible. And the other option is that you actually come with an idea of a project, so you can propose that to the supervisor and you craft a research project that is tailored on you. Yeah, what's the most exciting research currently happening in aerospace at University of Auckland? So from my side, I think I mentioned we have this project with the JPL, where we basically are trying to design a cislunar mission, and one area is to control mission very low on the lunar surface, and this is extremely challenging because the gravitational field of the moon is highly irregular, so it's very easy to impact on the moon. I had another project with the Curtin University in Australia on a little device that you can bolt on every spacecraft in order to improve their tracking, so that enable safe operation in space. But it's not only me and the institute. So for example, the director has a very interesting project with a company in Germany, that is Bioma, on deployable baffle for a space-based telescope. There is some research on drug sales, and there is also a spin-out company at the institute too. And other project, for example, laser comm in collaboration with DLR in Germany. Next question, will I be able to move into a PhD after doing the master program? What about if I only do the postgraduate diploma or postgraduate certificate? Yes, so PhD is a possible next step after the master, and it will be particularly good if the PhD builds on the research project of the master. If you take the postgraduate diploma or a certificate, you can go to the PhD, but you need to have completed a research project before, because this is a requirement for enrolling in the PhD. So having worked with Rocket Lab, what are the most important academic research areas related to guidance, navigation, and control? I guess this is for AJ.
I mean, I can only really speak for Electron, but well, for example, we're doing a mission this year, which is a rendezvous mission, and so it's quite similar to my research project I did with Roberto, where I was doing rendezvous missions, but between like spacecraft going between two planets rather than two orbits around the Earth. So there's some use for guidance algorithms. Neutron is also exciting. It's quite a bit different. It's a landing stage 1, so navigation is really important in that. So learning how GPSs work. Yeah, and then I guess you mentioned there's some propulsion knowledge at the university as well. We're building a new engine at the moment, the Archimedes for Neutron, so that could also be useful.
So with this, I think we are coming to an end of the webinar today. Thank you to the audience for attending and sharing your question. And thank you, Lilian and AJ, again, for being ambassador of our Master of Aerospace Engineering. And I hope this webinar has been informative. And if you have further queries, please refer to our website or contact us through Ask Auckland online, and this is available through the description box. We look forward to joining us as a master's student in aerospace engineering, and enjoy the rest of your day.